go. Factor each. So you guys, everybody pay close attention. This is either going to help, you're either going to not be able to do today's assignment due to this thing, or you will. So let's look at each of these and let's factor them. Now guys, before you start trying to factor, if it's quadratic, before you start doing a quadratic factoring, look and see if there's something in common in the beginning. So let's look at this first one. It's not quadratic, but what's in common in each, what's in common in each term? A 5. The greatest thing in common is a 5. So we pull out a 5. Now technically what we did was we divided each term by 5 to see what's left inside. 5x divided by 5 is x, and then 25 divided by 5 is 5. So x plus 5. So this is what 5x plus 25 factors to be. Okay, let's look at this next one. 2x squared minus 3x. Well, it is quadratic, yes, but let's make it easy on ourselves. Before we start going what multiplies to be a times c and adds up to be b, is there something in each term right here that can factor out? Good, let's pull out an x. So we divide each term by x to see what's left. 2x squared divided by x is 2x. Negative 3x divided by x is negative 3. And we're done because we're down to linear factors here. We're all good, right? So far? Okay, next one. X squared minus 8x plus 16. Can we factor anything out right now? No. So it's quadratic. There's nothing we can do but say, okay, luckily this one's quick factoring. So we always do what multiplies to be a times c and adds up to be b. A times c is 1 times 16. So positive 16 and adds up to be negative 8. What are factors of 16 that could add up to be 8? 4 times what? 4. And they both have to be negative, right? And it works in both cases. Negative 4 times negative 4 is positive 16. Negative 4 plus negative 4 is truly negative 8. So it works in both cases. Now because that a value is a 1, we can quick factor this. So it's going to factor to be x minus 4 from that minus 4 times x minus 4 from that minus 4. And we're done. We factored it. We are going to have long factoring today though. We are going to have long factoring. So we're going to do one to review. Yeah. Oh yeah, that's a good point. You could write x minus 4 squared. Yep, that's awesome. You could do that as well. Okay, let's do a long factoring one. Because we have to be able to long factor. There's no way around it. And guess what? My secondary math 2 students, they can long factor like it's nobody's business. So you should be able to. Let's go through this one. Here we go. So guys, here we go. We're doing what multiplies to be. Well, let's first look. Is there anything in common we can pull out to make it smaller? No, right? So we've got to just bite the bullet and do it. What multiplies to be negative 45, a times c. So what multiplies to be 5 times negative 45, which is negative 225. What multiplies to be negative 225 and adds up to be 16. So guys, just start listing out factors. 225 divided by 2. Nope. 225 divided by 3. 3 and 75. 225 divided by 4. Nope. 225 divided by 5. 5 and 45. 225 divided by 6. Nope. 225 divided by 7. Nope. So 9 and 25. Okay, let's check these ones, see if any of them can add up to be 16 possibly. 3 and 75, no. 5 and 45, no. How about these? Yes, which one would need to be negative? 9. Now check it. Does it work in both? Yep, that is negative 225 and negative 9 plus 25 does equal positive 16. So now we have to drop and break. Drop and break. So we drop down our n term. So we drop down 5x squared. We drop down negative 45. I should have done that over to the side better. So we drop, and then we're breaking down our middle term. We're rewriting it as negative positive 16x as negative 9x and positive 25x. Don't forget the x part. So negative 9x, positive 25x. Everybody comfortable with this? It's not new. Just remembering how to do it. Throw parentheses around the first 2, around the second 2. Factor out what's in common in that group. And x is in common, right? Divide each thing by x. Left is 5x minus 9. What's the greatest thing in common here? Positive 5. So we pull out positive 5, divide each thing by 5. left is 5x minus 9. And our safe haven's good. If that's not exactly the same inside the parentheses, sign and all, you've done it wrong. So we factored out our safe haven, factored out 5x minus 9, it divides out, leaving us with x plus 5. So guys, that wasn't that bad. It wasn't that bad. We're okay with factoring. That's actually going to be one of the ones off the worksheet. So we've now factored it. So if you do your worksheet and refer back to it, you can use it. Okay, awesome. Okay, let's get to it. I really want to give you as little homework as possible. Here we go. So, first of all, we're going to be simplifying rational expressions and adding and subtracting rational expressions. We're kind of learning 2 lessons in one because we're just kind of short on time. All right, but you'll be okay. We've seen rationals before. So recall that rational means fraction. If you ever see the word rational, you know it's dealing with fractions in one way or another. An expression is just a statement with no equal sign. So once again, a rational expression is a statement with no equal sign. If we had an equal sign, that's a rational equation, and we have learned how to solve those. This is just an expression. So right here, this is an example of a rational expression. It's a fraction, and it has no equal sign. It's just an expression. Is everybody okay with that? Yes. Okay, awesome. Okay, so here are the steps to simplify a rational expression. Very important. The first thing you do is factor the top and factor the bottom into its linear factors. So you factor the top, you factor the bottom. That's the first step. Is everybody good with the first step? This is the most important step, the most common mistake made. People simplify too soon. So you factor first, and then second, you must restrict the domain. So remember, the reason we restrict the domain is because we're throwing out x values that will make our function undefined. So where are x values not allowed? In a fraction. The bottom cannot be equal to 0, right? So we're going to make sure that we restrict our domain by saying x cannot equal the values that will make our bottom 0. And then once we've done that, our third step is to divide out exact factors only. So we'll divide out, then we can simplify it. We factor it, restrict it, then you can simplify it. But that's the important part, is that you restrict the domain first. Before you start dividing things out, you have to restrict it first. Does that make sense? Now here's the reason. Some of those things are going to divide out, but those are still restricted values. So if you do not restrict the domain before you divide them out, you will leave out some of the restricted values. Okay. Now don't be the common mistake, guys. Don't be a statistic. Everybody, let's review a few things. Can I simplify something like this? X plus 9 over 9. Can I say, oh, 9's divide out? Absolutely not. Wasn't x and 9 both divided by 9? By dividing out just the 9s, you pretended like x wasn't. So you cannot do that, you guys. Do not be the statistic. So x plus 9 over 9, that is as simplified as it gets. Does everybody understand that? Okay, don't be the statistic. Look at this one. Can we say, oh, those 9s divide out? No, we cannot. That would be that. Okay, so you can't do that. That would be as simplified as it gets. Now, a lot of people will do something like this. Negative x plus 3 and x minus 3. And there's a negative, there's an x, there's a 3. So those simplify to be 1. Not true. Isn't this on the bottom if we were to, or even this one? Well, they're not the same thing at all, right? They're completely different. So we can't divide them out. That's as simplified as it gets. Does everybody understand that? Okay. Once again, 2x plus 3 over 3. A lot of you make really bad simplification things and you say, oh, 3's divide out. You guys, that is not, you can't do that. The 2x was also divided by 3. By dividing out the 3's, you pretended like it wasn't. Does everybody understand the math of why you can't do that? You better not do it today. But what about something like this? 9 times x plus 1 over 9. Can't the 9's, now that they're all factored, can't the 9's divide out and become 1? Yes. Okay, so we could do something like this. Now look at this one. 8 times x minus 2 over 4. Those two things can't simplify because 8 is not inside. I mean, even if, so because it's factored out, we can now simplify it. That would be 2 over 1. Does that make sense? Okay. All right, so here we go. First example. We're going to simplify and state the excluded value. So we have 20 over 5x plus 25. This is a rational expression. We're simplifying it. Our first step is to factor the top, factor the bottom. The top is already factored, right? Top's already factored. So I'm going to rewrite it. The top is already factored. The bottom, what factors out? 5. So we pull out a 5, and left inside is divide each thing by 5. Left is x plus 5. All right, so then we've done that. Before you divide anything out, you state the excluded value. So that's where the bottom is equal to 0. Well, the problem's right here, right? That's the only place we can plug something in, right? So you have to say, well, x plus 5 cannot be equal to 0, right? If that was 0 right there, wouldn't that be a 0 in the bottom? So now solve for x. Subtract 5, subtract 5. So x cannot equal negative 5. Does everybody understand? If I plugged in a negative 5 right there, that would become 0, and that would be bad. So x cannot equal negative 5. That's part of our answer. So I'm going to circle it so I don't forget. Okay, we've stated the excluded values. Now you can simplify it. So we have 20 over 5. Because it's all factored out, we're good. 20 divided by 5 and becomes a 4. 5 divided by 5 and becomes a 1. So our final answer is 4 over x plus 5. Right? Everybody?
Yes.
That is our answer, and x cannot equal negative 5. There's our answer right there. Are we all okay? Pretty simple, right? Okay, couple more. X minus 7 over 7x minus 49. Let's go through it. First step is factor the top. Already done? Factor the bottom. What's in common? 7. We pulled out a 7, so we divided out a 7. Left was x minus 7. Before you divide anything out, exclude the values. So x cannot equal, can you just look at this one and tell me? 7, right? If we plug in a 7, wouldn't that be 0? So x cannot equal 7. Okay, we figured out the excluded values, so now you can simplify. Now x plus 7, it could technically have parentheses. So let's see, exact factors. Do we have an x plus 7 on top and bottom? So we divide it out, it became 1 over 1, right? Does the 7 float to the top? Nope, it was in bottom. So we had a 1 on top and a 7 on bottom. 7 times 1 is just 7. So 1/7 is our answer as long as x does not equal 7. Yeah, we're restricting the domain. Because if we plugged in a 7 right here, we would have been in trouble. Does that make sense? It's undefined at that point. Okay, is everybody comfortable so far? A little bit more difficult. Here we go. 25b squared minus 30b all over 10b squared minus 5b. Our first step is factor the top, factor the bottom. Look at the top. It's quadratic. But what's there in common in the beginning? A 5 and a b. So we're pulling out 5b. So divide each thing by what you pulled out. Write what's left. What's 25b squared divided by 5b? 5b. Right, everybody? I can't tell if you guys are literally lost or you're totally getting it. So yes or no, are we all okay?
Yeah.
Okay. Negative 30b divided by 5b. Negative 6. Very good. Let's factor the bottom. What's in common? 5 and a b. So we're pulling out a 5b. Divide each thing by what you pulled out if you must. What's 10b squared divided by 5b? 2b's. Very good. Negative 5b divided by negative 5b. Don't say 0. Don't say gone. Good. It's a 1, so it's negative 1. Very good. Okay, before you divide anything out, restrict your domain. So where are there problems? There could be one right there, right? B cannot equal what? What would make this 0, guys? Negative 5 times 5 is negative 25.
0.
0, right? B cannot equal 0 right here. Do you all understand? Yes or no? Do I need to do the algebra? Okay, B cannot equal 0 right there. Also, right here, we would say, okay, 2b minus 1 cannot equal 0, solve for b. Add 1. So we have 2b is equal to 1, divide by 2. B also cannot equal 1/2, right? So b cannot equal 0 or 1/2, or 1, yikes, or 1/2. So those are my restricted values. Is everybody comfortable with that? That is a huge part of the test. If you can't get that part right, then you're not going to do well. Okay, we're not done now. Now we can simplify. Divide out exact factors. We have a 5b on top. We have a 5b on bottom. They divide it out, become a 1. Good. 5b minus 6, do we have that exact thing on bottom? No. So we're done. Our final answer is 5b minus 6 over 2b minus 1 as long as b cannot equal 0 or 1/2. There would be my answer. Is everybody getting it? We're all good. Jaden, I don't know how you're learning with your eyes in the back of your head, or you gotta watch, buddy. Okay? All right. Here we go. Last one here. X squared plus 13x plus 40 over x squared minus 2x minus 35. The first thing we do is factor the top, factor the bottom. So guys, it's going to take a little bit of brain power. You might need your own paper. This is not too bad though. Luckily, this one's quick factoring. So I'm just going to focus on factor the top. What multiplies to be 40 and adds up to be 13, right? So 8 times 5, right? Positive 8, positive 5. So it can quick factor. So it's going to factor to be, those two things. So it's going to factor to be x plus 8 times x plus 5. Did I go too fast, or is that okay? Okay. Let's factor the bottom. So we're doing now what multiplies to be 1 times negative 35, what multiplies to be negative 35, and adds up to be negative 2. And it's quick factoring as well. What are some factors of 35? 5 times what? 7. One of them has to be negative. Which one? Negative. Very good. And we can quick factor since our A value is 1. So it's going to factor to be x plus 5 on bottom, because it was positive 5 times x minus 7. Before you divide anything out, restrict your domain. So x cannot equal, for this piece, x cannot equal what? Negative 5. And for this piece, it can equal positive 7. So now we've restricted it, we can go ahead and divide out exact factors. X plus 8 on top, not on bottom, move on. X plus 5 on top and on bottom, yep. They divide out and become 1. So left on top was x plus 8, left on bottom was x minus 7, as long as x cannot equal negative 5 or 7. Are we getting the gist here? Okay, I think we're good then. Do 1 through 8. Ready, set, go. Okay, now I'm going to do some of my examples off of your worksheet. So let's go through it, guys. Here we go. Number 9. I'm doing number 9 with you. Now pay attention, please, to the little details. I'm going to give you a little few hints that's going to really help you. So let's look at number 9, 27x squared minus 63x minus 90. We could go ahead right here and start trying to do what multiplies to be a times c and adds up to be b, but that's really big numbers. So let's look in the beginning, can I factor out something before I start doing what multiplies to be a times c? What does 27, 63, and 90 all divide by? What number? 3, yes, but something even greater. 9. Don't they all divide by 9? So let's factor out a 9. So when we factor out a 9, we divide each thing by 9. And left is 3x squared minus 8x, and then minus 10. Now, isn't that a heck of a lot smaller? Now, if we need to factor out the inside more, yes. Okay, good. Now, let's factor out the bottom. What's in common here? Something greater, even. Don't they all divide by 9? So I'm going to factor out a 9 on bottom as well. Divide each thing by 9, and let's see what's left. So we'll have 2x squared, and then we have plus 5x minus 8. 7. Yeah. Why the heck am I putting 8? Minus 7. Yeah, not 8. 7. Okay, from here. Now look, does the 9 have a variable with it? No, right? So can't we just divide it out? Yeah? Okay, so the 9, because the 9 doesn't have a variable, those 9s can divide out. Alright, so now I'm going to factor the top even further. So now we are going to do what multiplies to be a times c, so what multiplies to be negative 30 and adds up to be negative 7. 10 times 3, the negative would have to be at the 10. We cannot quick factor, but we can long factor pretty quickly. So we drop down 3x squared, we put in a negative 10x, minus plus 3x, and we're dropping down -10. Do you see how I drop and break? Am I okay? What's in common right here in x? So then left is 3x minus 10. Now don't say there's nothing in common here. We can always pull out a 1. So I'm going to pull out positive 1, and left is 3x minus 10. Now is our safe haven good? Yeah? So we've done this correctly. Factor out your safe haven, 3x minus 10, and then left was x plus 1. So now we factor the top. It's that. 3x minus 10 times x plus 1. We were just factoring the top, right? That piece? X plus 1. Now I need to factor the bottom. So we're doing what multiplies to be? What multiplies to be -14, a times c, and adds up to be 5. It's 7 times 2, negative with the 2. Now we can't quick factor, so we drop and break. So we have 2x squared minus 7x plus, oh, it was plus 7x. Plus 7x minus 2x minus 7. We're almost there. Group. So we pull out an x. Left is 2x plus 7. When we have a negative in front, we pull out a negative. It looks like just -1. So we're pulling out -1. And left is 2x plus 7. Now our safe haven's good. We pull it out. 2x plus 7. Left is x minus 1. And that was the bottom. So bottom factor to be 2x plus 7 times x minus 1. Okay, from there, before you divide anything out, you have to restrict your domain. So looking at the bottom, you look if there's a variable. Set that piece equal to 0. So we're going to set, I need some room. So I'm setting 2x plus 7 equal to 0. 2x plus 7 equal to 0. I'm setting that equal to 0. X minus 1 equal to 0 and solving. So I subtract 7. So we have 2x is equal to -7 divided by 2. So x cannot equal -7/2, and also add 1. X cannot equal 1. Okay, we've restricted our domain. And then we divide out exact factors. Are there any exact factors here? Nope. So that's our answer, as long as x is not equal to 1 or -7/2. Questions? Questions? Okay. All right. Do you want me to do number 11, or are you ready to just practice on your own?
We're good. We're good.
Okay. Do 9 through 12. Ready, set, go. A couple more so that we can finish up that page. So, guys, I really shouldn't even have to do this problem, but I'm going to. So pay attention so that you can make sure you can do it. It says, what's the ratio of width to length? So if we're given the length and width, this is my length, this is my width. Okay, well, let's think about it. Length, it said, what's the ratio of width to length? So ratio means division. What? It said of width to length. Which one came first? And this one width did. So that goes on top. So you're saying x minus 2 divided by length 4x minus 8. Well, that is the ratio. And then simplify it if possible. So on top we factor it. It's already done. On bottom we pull out a 4. Left is x minus 2. This is the ratio of width to length, and then we'll simplify it. We don't have to restrict the domain on this one, because we're just finding the ratio of width to length. Now, this is more like what you see on an end of level, because it's testing your knowledge that you know how to set up something, and now it's testing, do you know how to simplify fractions? Okay, so rational expressions. Here we go. So, don't they both divide out and become a 1? Don't magically float that 4 up to the top. There's still a 1. 1/4. Look at that. The ratio of width to length is 1/4. Is everybody comfortable with that? It wasn't hard, was it?
No.
Okay. Next one. It says, what is the width? This is more like what you'd see on an end of level. So what is the width? So we're given the area, we're given the length. We want to know the width. So let's think about it. Isn't area equal to length times width? Right? Let's plug it in. Area is x squared minus 49. So we have x squared minus 49 equal to the length, which is x minus 7, times by the width. Now to solve for width, wouldn't we just divide both sides by x minus 7? Yeah? Does everybody get what I'm doing here? So divide both sides by x minus 7. So then width is all by itself. We solve for width. It's that. But does that simplify? Let's see. Let's factor the top. So you're doing what multiplies to be. Do you guys see what I'm doing here? Do I need to write it out? We're all okay about how I solve for width? Okay. So now I'm doing what multiplies to be negative 49 and adds up to be 0. Right? B is 0 in this one. Isn't B 0 in this one? 7 times 7. One of them has to be negative. Our factors, and we can quick factor because that's a 1. So the top factor is to be x minus 7 times x plus 7. And that's all over x minus 7. And that is our width. We're almost done. Does that simplify? Yep. X minus 7 gone. So what's our width? X plus 7. Are we comfortable with that one? Okay, so you should be able to finish all of page 1, and I'll give you a couple minutes, practice some of those, and we've got to move on. Some of it's going to be homework. Moving on. Some of us are going to have homework, and that's just kind of the reality of it. Okay, so when adding two fractions, everybody look with me. This next part's the easy part, though, so that's good. Now we're into the easier stuff. When adding two fractions, like 2 thirds plus 4 thirds, we have to have a common denominator, right? Yeah, so this one does. So if we added this straight across, that would be 2 plus 4, which is 6 thirds. Now notice, did I add the bottoms? Did I do it add an extra addition of the bottoms of the denominators? No! You don't add up the denominators when you're adding fractions, right? Is everybody good with that? Okay. Alright, so that goes the same with rational expressions. So here we go. Steps to adding and subtracting rational expressions. First, factor out the top and bottom of each piece. Second, get a common denominator by manipulation. We've actually practiced this from the last test. Third, add or subtract the top parts. Combine like terms on the top. And you have to be careful with subtraction because you might have to distribute a negative through to multiple things. And then fourth, it's the simplified top over the common denominator. So we actually did this on the last test. So it shouldn't be new. So here we go. All my examples are coming from your worksheet. Let's get this done. Here we go. 1 over a plus 1 over a. First step is to factor everything. Isn't this one factored? Okay, second step is get a common denominator. Isn't it already common? Yes. So now you simply combine the top all over the bottom. What's 1 plus 1? So we have 2 over a. And we're done. That one was starting out really easy here. Are we all okay with that? Let's do another one. Don't just say, okay, I get it, and then not watch. Because that's what some of you did, and then you said, well, I don't get it. Okay? AKA table 1. Here we go. Here we go. Is this one factored? Is this one factored? Yes. Yes, it is, right? Everything's factored. Do we have a common denominator? Yes. Yes, so we can combine the top. Be careful. This is subtraction. Aren't we subtracting all that stuff? Yes, so now we're just simplifying the top. So let's do it carefully. That's like negative. Cross the line, change the sign, right? I hate that saying, but that's just quicker, so I'm going with quick. All right. T plus negative t is gone, right? Negative 1 plus negative 1 is negative what? 2. So we have negative 2 over t. Is everybody comfortable?
Yes, ma'am.
No questions?
No, ma'am.
Stay with me. 11 over 2y plus 27 over 2y. It's all factored. And we have a common denominator, so we just simply add. 11 plus 27. 38 over 2y. Now look, does 38 and 2 simplify further?
Yes.
Becomes a 19 becomes a 1. So we have 19 over y. Everybody's feeling okay? Okay, we're about to get there. Oh yeah, probably a little bit more of a difficult one. Here we go. So, number 5, n over 1 minus n plus 1 over n minus 1. Are the denominators exactly the same? No. So guess what I'm going to do? I'm going to couple different things here. I'm going to rewrite this one as negative n plus 1. Isn't that negative n plus 1?
Yes.
Okay, awesome. So I'm rewriting this piece as negative n plus 1. Now, if there's a negative in front, we always factor out a negative. So let's factor out negative 1. Now let's see what's left inside. N minus 1. Divide each thing by negative 1. So that would be positive n. Positive 1 divided by negative 1 is negative 1. So everybody see how this piece factored to be this?
Yeah.
I'm not convinced by some faces.
I'm convinced.
Okay, so what we have is n over negative 1 times n minus 1 plus 1 over n minus 1. We need a common denominator. This has a negative 1 and an n minus 1. This one has an n minus 1. What does it need? Negative 1. So I multiply the bottom by negative 1, the top by negative 1. I need to get a common denominator. So now we have a common denominator. The bottom can't go away though because we're not solving. So the bottom's still there. But ignore it for a minute. Let's combine like terms. Well, what's 1 times negative 1? So this piece is negative 1. So let's combine them. What's n plus negative 1? Just n minus 1, right? N plus negative 1. So we have n minus 1 on top, and on bottom we have negative 1 times n minus 1, right? Is everybody following me? Do we have exact factors now?
Yes.
Yes. We have an n minus 1 on top and an n minus 1 on bottom. They divide out and become a 1. 1 divided by negative 1 is?
Negative 1.
Negative 1. Okay. Good. Questions on that? Okay, number 11. 2 over x minus 1 plus 10. We need to get a common denominator. This one always throws people off, but it shouldn't. This is just 10 over 1. So our common denominator is x minus 1. Hey, McCade.
What?
I need you to focus, buddy.
I'm focused.
No, you're chit-chatting and singing and acting and doing a little jig instead of math. Okay, so right here, we're going to multiply by x minus 1 over x minus 1.
Yes.
So we have a 2 up here. Let's distribute that through. Positive 10 times x is positive 10x, right? Positive 10 times negative 1. Negative 10. And then it still has a 2, right? And it's all over 1 times x minus 1. Are we all following me?
Yes. Yes.
Yeah, so we'll just write x minus 1.
Yes.
So combine like terms. 2 minus 10 is negative 8. So we have a 10x on top minus 8. I just combined 2 and negative 10, and I got negative 8. All over x minus 1. Now, nothing factors further. I mean, the top I guess could. I'm not going to be that picky. These don't divide out, so we're good. I'll accept that answer. Any questions? Okay, number 16. We're almost there, guys, and then you'll just have the rest of the time to work. We're really almost there. What? This one's probably one of the hardest ones because this is what a lot of you do. A lot of you do it. So everybody look up here. You say, okay, common denominator. This has an x, this has an x minus 1. You think you can magically make it minus 1, and you cannot. We're multiplying here. If you multiply by negative 1, does that become x minus 1? No, it becomes negative x. So you have to multiply by an entire x minus 1. So this one has an x, it needs an m and an x minus 1. So I'm going to multiply by m and an x minus 1. And I'm going to do that to the top and bottom. This one needs an x, so I multiply the bottom and the top by x. Okay, so now on top, you can distribute this through a few different ways. N times x, n times negative 1. So we have mx minus n, and we're multiplying that all to n. So m times mx is m squared x, n times n, negative m squared. And then we're going to distribute this piece, x times 4 is plus 4x. All over the common denominator of x, x minus 1, and n.
That's all.
That's it. I don't know, it's not too bad, I don't think. Okay.
Stop.
Finish the worksheet. Careful when subtraction. So you have to distribute the negative through to both. Okay.
What was the bottom?
The common denominator, x. So I probably would have, if I had to rewrite it, and if I had a second chance, I'd go like this, just for my own comfort. Yeah, that looks prettier to me. Same thing though.
Good.